this video, I'm going to show you various ways of copying a list in Python. We found this solution on Chang Gyo's blog post at the URL shown here, and Chang agreed to let us create this video based on it. First of all, I'll just create a list, which I name old list, and it's just based on a range of 2,000 characters. So go ahead and create that list. The first method is to use slicing with no start and no stop to create a copy of old list, and we'll name the copy new list. And then on line 2, we just check to make sure the two are equal to verify that it is indeed a copy. In the second variant, we set new list to an empty list, and then we extend that empty list with old list. Again, it outputs true, showing that old list is the same as new list or is equal to new lists. The third variant, we set new list to list. We use the list constructor and we pass it old list. That works as well, true. In the fourth variant, we import copy, and then we set new list to copy.copy old list to create a copy of the list. Again, that worked. In this fifth variant, we set new list to a list comprehension, I for I in old list. So we're going to iterate through old list, creating a copy of it element by element. And that works. In this sixth variant, we're going to actually loop through with a for loop. So we set new list to an empty list, then for I in old list, new list.append. We're appending each element on an element by element basis. We'll check it. Old list equals new list, true. Okay, in this seventh variant, which is a little different, we import copy and we set new list to a deep copy of old list. So new list gets copy.deep copy of old list, and that works. So all the methods work. Of course, you would expect that some methods are more efficient than others. Turns out most of the methods are very quick and about the same speed. We're going to use time it here to test the different methods, and I will run them all by selecting cell above and run all in IPython Notebook. And you can see starting on in 17 here are our time its, and the first one is 8.23 nanoseconds per loop. The next one is 6.89 nanoseconds, then 6.05 nanoseconds, and 6.99 nanoseconds. So you see those are all super fast, those first four. The fifth one, where we use a list comprehension and create it on an element by element basis, is understandably slower. So that's one we probably want to avoid. And the sixth one also, where we loop through, I have that out, but it's the same thing as this. That's again one we want to avoid because it's creating a copy of the list on an element by element basis. And then this last one, where we do a deep copy, that's the slowest of all. We're not even in nanoseconds anymore. We're in milliseconds, 1.61 milliseconds. Still pretty quick, but a lot slower than the others. So we want to avoid that unless what we want is a deep copy. So why is a deep copy so much slower than a regular copy? Well, I'll explain why here. Imagine we have two lists, A and B, and A is just 1, 2, 3, 4, 5, and B is A, B, C, D, E. And then C is a list of those two lists. D is a copy, using the copy method of the copy module, of C. Now, let's see if the first element in D is the same object as the first element in C. So we're using is here, not equals equals. We're checking to see if they're both referencing the same object. And when we run it, it's true, they are. So when we use copy.copy to make a copy of the list, we're copying the list, but we are not copying the elements within the list. What we're doing is using the same references that C used and referencing those same objects. That's why they're equal. If we use deep copy instead and run this, you can see that they're not equal. So in this case, each element within the list, each object within the list was copied. And that's why deep copy takes much longer to run. So unless you want a deep copy, you should probably avoid it. I hope you found this helpful. Thanks to Chang Gyo for letting us use his post as a basis for this video. Check out his blog at the URL shown here.